Javier will help me to the demos. Hello, good morning. We are ready to start. Well, for me it's a pleasure to present today. Please wait, wait. I will indicate when to move. To present this work, we will talk about collaborative modeling. We build on top of Orca. It's a product we have, and we use CRDTs. We will explain what it is, this thing, the CRDTs. First of all, I want to say thank you. Wait, please. Wait, please. Say thank you to Matthew Weidner. Matthew Weidner was a PhD student. Now he's a doctor. He already finished in June. He's from Carnegie Mellon University. We contacted him at the first of the year because he is one of the experts in this field. So we wanted to do the thing right the first time. So let's try to work with the good ones, with the better we can find. So we are very thank you to be able to find Matthew, and he was very helpful to work with us. So Matthew is our reference in this field, and we learn a lot from him. He is in the US, was not able to join here today, but the second colleague is Javier, that is already here. I want to introduce you before starting. Javier Centeno is our main developer at Orca and also at Daga, the libraries that are able to do that. And today here, you know me, I'm only the speaker. So the kudos for these guys, okay, first of all. Okay, now we can go. So, okay, the code for the question, just in case, is DV48, okay? And then we will go directly to the demo. I think it's better. Please keep going to the next one. Okay, so we have, why we are doing this? Basically, we want to be able to build 3 use cases. We come from a pandemic. We want to enable remote work. You know, we all have been there. So if you are at your home and you need to collaborate with others, how we can do it? And in the modeling space, sometimes you used to open Eclipse, MPS, some heavy monolithic application, and you work alone, basically, and hopefully you will exchange model or Excel files, you're not lucky, with your friends, no? And synchronizing these kind of things is complicated. Maybe Git, okay, in some cases. So another one is we should use online real-time collaboration. This is the first use case we want to support, but also to think about offline work with automatic reconciliation, in the way that you can pick a flight, you get loss of connection or entering a tunnel, and you want to keep working, and when you have connectivity back, let's be able to reconciliate as automatically as possible, so everything works smoothly, okay? We are get used nowadays to work with Google Suite, when you can edit documents and spreadsheet in real time with others. We have this feature also in Figma. You have this in Office 365. So we are get used already to these kind of features. So why not to bring that capability to modeling is what we want to achieve, please. So now let's do the demo, and then we can go to the details. Okay. Alt tab. Okay, so let's start with this one. Okay, this is Orca. This is a graphical tooling we created last year to edit graphically Docker Compose files, okay? So we can drag a couple of boxes. You can drag and drop just a public, a container. So we can connect a public with a container and add volumes and things like that. But this is not the funny way to do it. So now let's go to the system. So here this is like. Okay, let's do an example. We can do, I want a blog. Let's type, please. I want a blog with WordPress and MySQL. You know, this is like, in Spain, we write a letter as a kid to the 3 wise men in Christmas to asking for gift. So you can ask the wizard wherever you want. Okay, blog with WordPress and MySQL. This go to, in this case, ChatGPT. ChatGPT will hallucinate for us a model, and we will convert it graphically to a representation. So you can click in WordPress, please. Yes. WordPress, you can see we have some default values with the parameters that we need for that. And for MySQL, the same. We have the image, please show MySQL. So we have a starting point. Then we can keep adding networks and validating these things. And when we feel this is okay, we can show the export part, maybe. Export, please. So here we will get some valid Docker Compose file. You can set up, launch, and get running quite fast. Okay, so this is the main workflow to work alone, right? But we need to collaborate. Okay, so we can come back, and then let's do it. We have a button there over there to share. No, wait. No, not so fast. Just share. So here we will copy the experience of sharing and the interface. So we can enable the sharing thing just to enable the collaborative sharing. And now here we get a unique URL. Okay, we can pass to colleague to be able to do that. Now we can split the screen in two. Okay, and the other one is over there already open, the last one, that one. Okay, so we can click, we can put, no, it was in with a good place. You can paste the URL, and now we have the same diagram. You can see, yeah, now it's synchronized. If you can come back to the first one, yes, and close it, and now close this also to have some, you can adjust the zoom maybe you want. Okay, and now maybe yeah, add something. Could maybe a volume, network, whatever you want. On the left, it will appear on the right. The guys in the right, you can do some changes, change the label, name, whatever. Connect something. So in this case, it's locally, but this is synchronized on a server side. We have a server side. We will enter in the details quite soon. So dependency of the latency you have, you will expect to see to be real time mostly, or you will get some delay. But so far, if the connectivity is good, you can feel it in real time. So at the same time you are changing and you are doing changes, you will see that we have some feedback. Do some changes. We will see some notification here that your partners are doing changes. By the way, if we phone with a URL and give the URL to you, you can enter into the room and start doing things with us. You can put multiple people to work here at the same time. Okay, so you see the. Be careful with that. Okay, so we are adding things. Okay, so let's now show the changes. Okay, in the share button, yes, we can say here we have the list of persons connected. This is simulating Pedro here and Alicia, Cyberpunk here. Okay, and if we see the chain log, please, here we have who did what and when. Okay, so far it's working quite well for this model, and we are reconciling the changes and working on it. Now, I think we need to come back to the end of the demo, right? Successful demo, and now let's explain how the details for that. Okay, so what's going on here? The main problem to deal with is the merging problem. How to resolve the problem of getting asynchronous messages with delta and changes, and to be able to synchronize them. Okay, so we need to do some kind of ordering of actions in time. So you need logical clocks or vector clocks to be able to order things in time, right? What was added before any other actions, and to order them in time. So we need to. It's not always possible to have real-time synchronization with clocks on different machines, because maybe your partners are in different time zones and maybe your clock is not perfectly adjusted. So it's better to rely on logical clocks for this kind of task. Also, there could be some scenarios with there will be ambiguities and contradicting actions. Talking yesterday in the dinner with Nico, he showed me a very nice one to investigate. I think we didn't address that yet, but of course this is we are let's say there are a lot of edge cases we need to consider for sure. But depending on your scenario and the semantic of the model you are building, if you treat all the cases, you could be fine. And we think so far, with the testing we do with the kind of diagram we build, there are no edge cases so far. Let's continue with that. So to fix these problems, we use CRDTs. Okay, this is the acronyms for conflict-free replicated data types. That is a bit complicated, or as Matthew used to call them, is collaborative data structure. So there is a mathematical data structures that a lot of computer scientists and mathematics has researched over the latest years to how to deal with this problem, how to have a distributed set of changes, and how to make that all of this is finally eventually consistent, right? And this can be applied also to blockchains and things like that have to be consistent at the end with changes coming from different places. So based on that, there are already well-known data types working very well for list, string values, literal values. Trees are a little bit trickier, as Nico pointed out. It's true, but you can do things. You can do things with these kind of things. We will need to, as commented before, rely on logical clocks, and moreover, there will be cases where there will be ambiguities. So we will need to provide design choices on top of that, and mainly based on the semantics on the DSL you are building. For example, you can choose for that for one scenario, the first chains win, or the last chain win. Depending on what you are doing, you can decide on one or the other. Or you say, no way. Let's wait for having all the changes. Just pop up to the user, and he will. It's a complex thing, so it's better for them to resolve like a merge in Git that is cannot be automatically resolved. So let the user choose, just in case to be safe. So, but it depends a lot on what you are trying to do. So here we have a very simple example, and this was the application from Apple, right? That there's already works there. Yeah, I know Notes application in some device, we are get used to this, right? So the idea here is that, okay, we should put apples to buy apples. If we have connectivity, it will synchronize to the laptop. Keep going, please. Now we lose the connectivity, we add bread, we add coffee, and keep going. Now suddenly we get connectivity back, yeah? And then we expect that the coffee will synchronize this side and the bread synchronize the other side. That's more or less how things should work, okay? So, and at the end, eventual consistency is achieved. How we arrive to that point, how we do it? Well, first of all, we need to set up an architecture to do this. So we decided to have a central model server. So we have some server on the cloud that is synchronizing the clients. Otherwise, different clients, different browsers probably are in different IPs. They were not able to talk each other. So you can go for a solution that could be fully distributed with no central servers. But for the kind of thing we wanted to build, like Google Docs or any other, follow a similar approach. You put a central server with scalability in place, and then have sessions open with all the people connected to be doing the collaborative editing, right? To build this, we are using JSON messages to interchange the deltas with the server, and also, please await, don't go too fast. And we use WebSockets, okay? We use WebSockets. Later on, if we need for better for speed or with the size of things, maybe JSON could be replaced like protobuf or any other binary protocol. But so far, it's working well. Please go on. Okay, so key decisions. So we need to add meta modeling support to support the primitive for collaborations, and of course, this is an opinionated solution to build an example of the things we want to build. There are more solutions to this depending on your requirements, basically. Okay, so we implemented in Daga first. Daga is the library we use for all the graphical modeling we use. Orca is a first real application we have for Docker. But the way we decided to do it in the common library means that all the future graphical DSLs we build later will have this capability ready to be used with lower cost. Then we use it into Orca, what you have said. So central server, it could be cloud or on-prem, but there is some central server when you have the repository with the source of the model. So the communications are done via WebSocket and JSON, as commented before. We have security in place in the way you need to authenticate at this moment with OAuth, okay? But we can refine the security to use whitelisting, for example, you know? So you can have a whitelist of the people you want to share with, and if they are not in the list, so they cannot access. So we can have finer authentication on that, okay? And we wanted to work on this to have the usability as simple as possible. The shared metaphor that you have seen, we are get used to it, to Google Docs and other kind of applications. We work with Paco, or designers. That this is a nice. Paco is not here. He will come later. He put a lot of emphasis to build the simple UI we can build, and we take these usability things quite seriously to be able to serve our final user that probably is not a technical one. Okay. Okay, please go in. Here we have an example. You see that we have a share button. You expect to have something simple to share with others. Here you have the list of people connected, if they are online or not, and the changes. So, you know, the UI is quite intuitive. Nothing complicated to explain. So, one click, please. Yes. Next, please. Yes. So, what implication we have on the model? Well, we need to add extra metadata. For example, for everything you are going to build in the model, you have to add unique IDs, right? Unique IDs just for tracking, for referencing, so to have the deltas correctly identified. Maybe these IDs could have a computer or user identifier to know where they're coming from. Okay, it has to be unique. That's it. Later on, we need to provide logical time tracking. Okay, if we use certain kinds of GUIDs, there is a specific version of GUIDs that have some matching identifier that is unique. So you are also getting where the chain are coming from and unique timestamp for that machine. So that's help. Okay. And also, we will have to deal with logical deletion, and this not be able. It's not easy now to delete something and forget about it. No, you mark it as deleted, but others still didn't delete it yet. And moreover, when you use aggregation, okay, sometimes you will delete a class. Maybe all the attributes or properties are built behind this class need to be deleted also. So we will need to do cascade deleting. Okay, let's go to the next slide because we have a slide for that. So let's suppose we have this model, and let's decide to delete something. Please click. Now we want to delete container A. Okay, this is the operation to perform. We delete the container A, but we need to also to delete the property, the relation with the container B, and the relation with the volume. So in memory, we have this. We mark is tainted in the way that we annotated. We need to delete that. But it's not yet really deleted. It's a logical deletion. Okay, so in the next phase, please click. Now we want to have the canonical model. No, only one click, please. We need to filter the model with the deletion. At the end is only these two orange boxes. Okay, so we need to have mechanisms to filter away the removed things, so we have a canonical version or a snapshot with a final model in this case. Okay, keep going. Okay, behind the curtain, we have a protocol for communication between clients and servers, and just because the library is called Daga, we decided to call this Esgrima. Okay, Esgrima is like fencing, right, in Spanish. Okay, so there are some couple of messages we interchange via the WebSocket, and we can go to the browser and try to look what's going on, and you know, we can see the details here. We can show you later. So here we have some messages. We have hello when you connect to the server, bye to say bye-bye. If you want to create a room for collaboration, you call a special message for creation of the room, and confirmation. When some people enroll, we will use this message, and so on. And when you add data, we have the add command, and another one for error control, and so on. So let's show the next one. Let's use this instead of this. This is safer. So let's suppose we have a sequence diagram. Let's suppose that Alice, please click, decided to create a connection. Hello, create a space for collaboration, please. So the model server says, okay, your room is number 42. Okay, keep going. Now we start adding things as we do before, and then Bob connect. Hello, I want to enroll in room number 24. Okay. 42, sorry. So we have confirmation, and all the changes that we already have are ready for Bob. Keep going. Now Bob participate, add something, and we propagate. Okay. keep going, bye. Bob disconnected. Only one click at a time, please. No. You, te he pasado. One click per time. Now, Bob disconnected. Alice, keep adding things, and we can keep going. We can decide to open another room if we want. More people can join in, but just to explain the basic. Now let's move to the second scenario, the disconnected one. It's quite similar to the previous one, but let's do it. So the same thing starts the same way, and suddenly Bob will disconnect. Here, stop. Here, Bob disconnect, enter in a plane, lost connection, but he want to keep working, right? So now I choose another color to show that this is done in a disconnected way. Keep going. In the meantime, Alice is already connected and keep adding things, or not. Maybe it would be disconnected and working locally because we work things local storage in the browser, right? When you are ready to go, or Bob finish his travel and get connection again, you will reconnect, and now the servers know what changes are missing, so you will get all the missing parts, and then you click another one, please, and you will get the changes from Bob also, and we will propagate it to Alice. So on the client, there is all the rule to resolve these deltas, so you will have the same, eventually, the same model on both sides. Okay, it's working pretty well so far. One click at a time, please. So some conclusions. We have explored CRDTs to allow online and offline model changes. So we incorporated this in Daga and Essential as the library as a foundation capability for our next models and diagrams or DSLs to have also this when it makes sense. So Orca is just the first practical example because we have to build the infrastructure to show something, and this is what it is. So we are ready to incorporate two other DSLs. So next step, we want to explore other domains that probably will need it. We will still need to test it with bigger models for sure, and to be able to scale for bigger model. Also to test it with more clients connected. We did test till 10 connected users and working pretty well. Maybe we can support more. Maybe the limit is in how many connection on WebSocket you can get on the server side. But if you have enough memory and CPU, I think it's doable. Okay. And also another interesting testing is what happens if we have a large session that is taking months, right? With connected people coming and providing. Maybe we will have some mechanisms to send things to database and recover and reiterate the state of the long period session over time, right? And as commented, security can be refined as needed in these cases. Okay, so I think we have everything, right? The next slide, please. So if you are interested about these topics, I recommend a lot the blog from Matthew Weidner, our colleague here in this, because he has a very detailed explanation about all of this technology and all of references. He did a PhD in the topic, so he's a well-known expert in the area. Yeah. And again, thank you to Matthew and to Javier, and that's all. Thank you very much. If you want to try this URL, you can try it too.
We still got some time for questions.
Which library did you use for the CRDT, or did you write everything yourself?
We built from scratch.
Yes.
Yeah. Matthew already have some libraries. We were evaluating which libraries to use. And based on the use case we wanted to build and the top capability on top of our libraries, he said, no, I think it makes more sense to build from scratch. In some other cases, yes, you can use well-known libraries for lists, but in this case, after reviewing that, we decided that the best solution was to do that way. Yeah.
And did you have to change the data structure to accommodate the CRDT?
A couple changes. We had to add timestamps for the last changes to some parameters. Yes, we had to do some minor changes because we had in the library that we were using data structure, the nodes, the connections, and we had to add some timestamps for saying this node was deleted, yes, but was deleted in this timestamp. This node was changed the position, but in this moment. Some minor changes to support that, but yes, we had to do some minor changes.
Yeah, mainly was extensions or decorations, if you want, more than changing something big in the meta model.
Or do you also have undo redo capabilities in the multi-user context?
Yes.
Control C, control.
No.
Why it does that? It's one of the actions that are supported as the changes you can do to the diagram.
Yes, it's supported.
If I may do a little follow-up. In a multi-user context, if two people change something, if person A does an undo, can it undo things that person B did? Or
no.
Is this like
Yeah. Undo redo is local.
Okay.
It's local. We talked about that, about doing a global undo redo, and after a review of pros and cons, we said no, undo redo is better to keep it local, because otherwise you will enter in other kinds of problems. Yes.
The collaboration service, is that also have a copy of the model, or is just
Yes.
a broker of events of change?
It's a broker, but it also serves as a way to store the model.
It has the server has the initial model and the changes performed to it. Then the clients get the model and the changes and compute the final state accordingly.
Okay.
But yes, at the end we store a consolidated version of the model or a snapshot whenever you want, server side.
How do you measure conflicts?
As commented before, with heuristics. You can choose that when there is a conflict, you can decide, okay, we'll apply a strategy to say the last one will win based on time or logical time, or not the case yet, but if you have a quite complex scenario, maybe you can show up to the user and let somebody to break the tie, right?
Okay. One last question. Yeah, a comment to the last question. Actually, you can basically go back in time, so you can look at the history.
Yes.
So
Yes.
that's a nice feature of this approach, because you have a tempo.
All the delta.
Temporal approach to it. My question is about the delete option. So if you're deleting elements that are chained, it's not always the case that you have to delete also the one you're linked to, because it depends on the type of relationship that is there. If it's a
Sure.
relationship,
Yes.
then you have propagation.
Yes.
If
If it,
that is very specific for your application.
Exactly. The reach of the boundary of the deletion you have to apply depends a lot of mainly aggregation. If you are doing aggregation, if I have an invoice with lines, if I delete the invoice, probably the lines you want to delete it, yes. But it's just a relation, direct association, but not composition, not aggregation. And also the cardinalities plays there a role on the semantics, just not to keep the model invalid. You decide, no, okay, I can delete the object, just broke the relation, and the other object stays.
So we've also looked at the same technology. It's really powerful, so I can confirm that it's a great asset. I think the main problem I still see with this technology is that the APIs that you're creating are basically custom. They are not standardized. So
Oh,
they are
yes.
made specifically for your application, and they do not care.
Yeah, but for example, we have standardized the communication protocol. We call it Schema. We have a project at GitHub. We are going to make it open source and to share with the community, and we will link with the session topic in Lion Web. We want probably to provide it as a foundation for Lion Web to be able to build on top of that and to get some kind of a standard to do this kind of things. So someone has to invite the future, so we are.
There are great extensions on graph libraries that put this underneath, and they are really powerful. So that's really worth looking at.
Yeah. Thank you very much. Thank you.